Hello, my name is Nathaniel Haynes, and this is a pre-recorded presentation for the 2020 meeting of the Society for Mathematical Psychology. And today I'm going to be presenting on anxiety modulates preference for immediate rewards among trait-impulsive individuals, a decision theory and hierarchical Bayesian analysis. So to begin, I'm really interested in trait impulsivity and how it develops across the lifespan. And so as a definition, trait impulsivity is defined as an individual difference that's characterized by a preference for immediate over delayed rewards, failures to plan ahead, and then also difficulties with self-control. I'll be focusing mostly on number one throughout this presentation. Down here in this chart, this is the sort of typical, what I might call the factor analytic type of understanding of trait impulsivity across the lifespan, where we have this sort of underlying latent, what we call externalizing liability, and we call this trait impulsivity, and then this predisposes one to develop things like ADHD, particularly the hyperactive impulsive subtype of ADHD and not the inattentive subtype in childhood. And then this can progress on to oppositional defiance and conduct disorders and in late childhood, early adolescence. And these are more characterized by things like very argumentative or maybe even getting into trouble, lying, maybe even breaking the law when at an age where a person can be diagnosed with conduct disorder. And then eventually this can also progress into substance use disorders and antisocial personality disorders in adulthood. Now, one of the things about this trajectory is that clearly not everyone who has a diagnosis of ADHD in childhood ends up progressing along this trajectory. But when we look at people who are diagnosed with ASPD, for example, typically they have followed a similar trajectory to this. And so one of the questions that I'm interested in is the mechanisms that can actually kind of push someone along this trajectory and how we can use that information to better come up with ideas for treatment targets, or just develop better theory, more mechanistic theory of how this happens. Now, one of the really important things to note here is what we observe in terms of trait anxiety. And so it seems that adolescents who have externalizing disorders in childhood, so things like ADHD, ODD, and CD, those who are high in trait anxiety tend to actually have, they exhibit less impulsive behaviors. So like fewer police contact, they're viewed better by their peers. We also see some neural differences, and I just have one example here. So differences in the gray matter volumes between those with high trait anxiety and those with low, generally lower antisocial or less antisocial behaviors. And there's even some evidence that those with high anxiety tend to respond better to treatment. And so I think this is really interesting because typically anxiety would be detrimental in other areas, but it seems to be useful in terms of protecting against impulsive decisions or impulsive behavior across the lifespan. And this can actually be summarized pretty well by Jeffrey Gray's early work in personality on reinforcement sensitivity theory, where the idea is that approach and avoidance motivations or valuations kind of compete to produce any given choice. And so that's sort of the framework that we're taking here. And the idea in this study was to come up with a way to get a better understanding of how anxious and impulsive valuation interact to lead to different types of decision making. And then to do this, we looked at, we had three different groups of participants stratified into 132 undergraduates who we anticipated would be sort of our sort of typical average impulsivity, maybe even lower than average. And so there's sort of like a baseline group. And then we screened over 10,000 MTurk workers, Amazon MTurk workers, and recruited in 800 of these workers who had self-reported some problems with substance use. And so this was just a couple questions. Either they're admitting to some sort of substance use themselves, or somebody has accused them of having some substance use problems. So not diagnosed with substance use disorders. And then finally, our third group is 35 individuals who were actually diagnosed with substance use disorders. And there was a sort of mix of different individuals with like alcohol and other types of substances, but I won't get into that now. Okay, and so the measures that we used here, so to look at trait impulsivity, we use the Barrett Impulsiveness Scale, in particular the non-planning subscale, which has been used in prior research to look at delay discounting, which we're using here. And so it was selected for that reason, but also because it has the strongest relationship to the sort of theory or the definition of impulsivity we used earlier. And then we also use the state trait anxiety inventory for looking at state anxiety. Sometimes this is interpreted as a general distress scale, but this is what we use in this study. And then also we use the delay discounting task as a way to look at how these different mechanisms may interact to produce changes in behavior. And so that delay discounting task, here's a simple choice from the task. You might be presented with something like a preference between $10 now or $15 in a week. And so you make a sequence of judgments in that way. And so to begin, here's just a scatter plot of the trait impulsivity and state anxiety scores. And really the big thing to show here is that in general, the students show, and the blue circles there tend to show the lowest state anxiety and trait impulsivity. The MTurk workers are somewhere in the middle, but there's a lot of variation because we have so many subjects there. And then the substance use disorder subjects tend to be in that top right quadrant with higher values on both. And there were significant differences in all of these directions in these groups. Okay, and so the approach that we took here was, as the title of the talk implies, we took a decision theory approach to do this modeling, and specifically, we kind of broke the task down into the different or the choice features that are available, and how subjects assign value to either of those dimensions. And so the first choice dimension or feature here is the reward amount. So this might be if I'm given an option of $100 in 2 weeks. A here is just the reward amount, $100, and then alpha, so this is a power function here, where alpha actually just changes basically sensitivity to changes in the amount. And so for really low alpha, or people with a really low alpha value, rewards are valued more so for their frequency than they are for their amounts. And so there's not really much differentiation between even really high differences. So things like 600 and 800 are subjectively very similar if I have a low alpha. Whereas if I have a very high alpha, the difference between 600 and 800 is still quite large. And so this is kind of vaguely interpreted as sensitivity to rewards and changes in rewards. So that's our first feature dimension. And the second one, of course, in a delay discounting task is the time dimension. This is typically the only one that's modeled in many applications of this task in clinical psychology, at least. And so here, this 2 weeks, we're using a hyperbolic function where a higher value for k leads to more discounting of future rewards. And so those with higher k's on average, we would expect to make the more impulsive choice more frequently. Okay, and so what we can actually do is just combine these together quite simply, where we have the reward valuation and then the delay discounting, and this gives us a value v for each of the two choice options on each trial. And then it's the comparison of the v, or the value, the subjective value, for each choice that leads to some probability of choosing the larger later reward versus the smaller sooner reward. And interestingly, when we put these things together, these two mechanisms, we get a really kind of interesting interaction that's useful to understand some of the interactions between impulsivity and anxiety. And so here is just a plot of the probability of choosing larger later in dark blue versus smaller sooner in dark red as a function of these different parameter values for this the one choice. And what I think the important point to note here is that if we look all across the values of alpha, regardless of what the value is, as k, or the discounting rate, increases, this always leads to more impulsive choice. Whereas across the values of k, alpha actually has a different effect. So if, in this example, if k is really large in that dark red portion, as alpha gets smaller, this actually leads to relatively less impulsive choice. Whereas if if k, sorry, the discounting rate is low, a lowering alpha actually leads to relatively more impulsive choice. And so this could give us a way to understand how anxiety actually can influence decision-making behavior in a way such that it might be protective for people who are very trait impulsive or have high discounting rates, but actually detrimental in some ways to those who have lower discounting rates or are less impulsive. And so to look at this, we used hierarchical Bayesian analysis, and this is a graphical model representing that, where we have in this outer ring, we have each individual, in the inner ring, we have each trial, and I won't spend too much time on this, but I'll go through a little bit of these parameter specifications here. So the beta weights at the very top are sort of like intercepts and slopes for sort of the average discounting rate, and then the effect of, in this case, either the trait impulsivity score or the BIS non-planning subscore on discounting rates across subjects. And so that effect is beta K1, sort of like a regression slope. And similarly, beta alpha 1 is the regression slope on the relationship between state anxiety and the alpha parameter across subjects. And so we call this the trait regression model, where essentially our predicted value for any individual's discounting rate or reward valuation parameter alpha is a function of their trait impulsivity and state anxiety scores respectively. And so the theory would suggest that we see a positive relationship between trait impulsivity, or the BIS, and K, indicated by a positive beta K1, and then a negative relationship between beta alpha 1 and the STAI, or the state trait anxiety states subscale. And then here's the specification for the individual level parameters. Like I said, I won't get into too much detail here. In the valuation function, we're using the valuation that I described on the previous slide. And then at the end, we have a logistic function that just looks at the difference between the value for the larger later and smaller sooner reward. And this is how we determine the probability of choosing either. And so we call this the trait model because the parameters and the subscales are linked in the predicted ways, but we also tested the opposite model, which we call trait incongruent, where we modeled discounting and alpha, assuming that state anxiety was related to discounting rate and that trait impulsivity was related to alpha. And so this just allows us to determine if the sort of theoretically predicted model actually performs better than this incongruent model. And then we also finally tested a base model where we didn't include the traits at all. So sort of an intercept-only model, just to determine if including the traits had any positive effect whatsoever. And what we actually did to look at improvements in performance was to do out-of-sample predictions on the substance use group. And so briefly, what we had done is fit this full hierarchical model to both the student group, the undergraduates, and the MTurk subjects. So fitting it to simultaneously all of those subjects, looking at their differences in traits and how that predicts choices, and then made out-of-sample predictions on the substance use subjects using only their trait impulsivity and state anxiety scores. And so essentially what we're doing is predicting trial level behaviors in this task using only the information we know about their personality traits, if you will. And here, this measure, the log pointwise predictive density, is sort of an expectation over the out-of-sample predictions. So we're using a full Bayesian approach here, where this value lower to 0 indicates better out-of-sample performance. And we found that for every subject, the trait model, where discounting rate is related to trait impulsivity and state anxiety is related to alpha, or reward valuation, that model performed best for all of the left out subjects. And so this is the model that we use to interpret. Okay, and so the general trend that we did find this positive relationship, so the predicted relationship between trait impulsivity scores and delayed discounting rates, and you can see the posterior distribution here on the right, where the values are much greater than 0, and so there's clearly a positive relationship here in the predicted direction. And then second, we found also the negative relationship between state anxiety and reward valuation, or alpha. And so both of these relationships appeared in the predicted directions, and I'll show on the next slide what this implies for a given choice. So here is an example kind of zooming into that plot I showed you earlier on the interaction between alpha and K for a variety of different choices and for the different groups. So what I'm showing you here is predicted changes or differences in choice between the groups just based on their personality traits and the range of personality traits within each group, and that's what the bars represent here. And so essentially what I want to show here, we can look at this one example in the top right. What you can see is how this interaction kind of plays out at the level of choice behavior, where all the information that's differentiating these groups is based on those trait impulsivity and state anxiety scores. And we can see that for those with a higher discounting rate in the substance use disorder group, lower alpha actually leads to relatively less impulsive choices, and then the opposite is true for the other. Okay, and so the conclusion here is that for the most impulsive individuals, increasingly high anxiety decreases the value of impulsive actions, and the opposite is true then for least impulsive individuals who, for increasingly high anxiety, actually increases the value of impulsive actions. And so this gives us a really nice way to understand some of those functional outcomes that we see across the lifespan, and it also gives us some ideas for things that we might do in the future to further kind of deepen our understanding in terms of how externalizing psychopathology develops across the lifespan. And so that's the talk. Thanks for listening. If you're interested in learning more, there's a preprint paper here, as well as all of the code, so the R code, and we used Stan to fit our model. So all of that you can find here, along with the data that we used. And a big shout out to my co-authors and my advisors, Ted Beauchesne and Brandon Turner, as well as everyone else who helped out with this project. So thanks again for coming.